For number 3, find the sum of the first 46 terms of the sequence. Here's your first term, here's your second term, and so forth. By the way, what do you think your common difference is? What is it that we're adding each time, do you think? -3, I think we can all quickly come up with. Do they tell us what the 46th term is? No, they don't. So we have two choices. We could either use this formula that is in the middle here, because that would say we don't even need that last term, the 46th term, in our formula to figure that out. And then we could work it out. Or the alternative would be to find that last term and then to use Carl Friedrich Gauss's formula, the formula at the bottom. But regardless of which way you're going to do it, I hope you'd see that you're going to wind up getting the same thing. You'd have S sub 46, adding up the first 46 terms. We'll have 46 all over 2. What's our first term? Well, our first term, I think we'd all agree, is a 2. And then if n is 46, guess what n minus 1 has to be? It's 45. And our d, you just found out, was -3. So at this point, we can just go ahead and clean it up. We'll say S sub 46. Well, 46 divided by 2 is 23. This is a 4 plus, and 45 times -3 is a negative 135, I think. I think that's right. And 4 plus negative 135 is actually just a negative 131. Not the friendliest numbers to work out here, but of course with a calculator we can finish this up in a hurry. We can just say 23 times our negative 131, and we'll be done in a second. Negative 3013 is our final answer. Okay? So that's what adding up the first 46 terms will get you. Okay, we doing okay? Yes?
Why do you use those kind of parentheses?
Well, I'm using those big parentheses, just to not completely have to use the ordinary parentheses. It's like so that you can see that's the outer bridge, that the n over 2 is multiplied to that entire computation, right? But you could use just regular parentheses and it's fine. Okay? Let's take a look at number 4. They'll say find the sum of S sub n. What's so different is how abstract this is. This is incredibly abstract. You'd say here's your first term, here's your second term. By the way, this last term is your nth term. Here's the world of difference. I know my nth term now. I can use Gauss's formula. Gauss's formula, and by the way, this can look rather strange because even the sum itself doesn't work out to a specific exact real number that we'll be able to see like our last problem. We can say, look, n is just n itself. My a sub 1 is an 8. And a sub n is going to be 3n plus 5. So we could go ahead and just work this out. 5 plus 8 is going to be 13. Okay, so we'll have 13 plus 3n. You could even leave this as is. What the author might have in the back, and by the way, talking about what Conrad was just bringing up, if you wanted to use ordinary parentheses rather than the blocks, it's the exact same thing. If you want to distribute that n in, you may. But that's what your nth term sum will equal. Yes? Because that's the formula that we see right here. You're going to always have n over 2 in that formula. So if I'm adding up to, like we did in the last problem with the 46, when I was adding up to that 46 term, I had to put in 46 over 2. Here, I'm not told exactly where I'm stopping. I'm just stopping at an nth term. So I have to do n over 2. Okay? All right, last one. Find this sum. And wow, this one's a little bit different. You can see pretty quickly what's happening. You could say, well, Our a sub 1 is going to be 60. Do I know my common difference? It's a 4. You can see we're going to continually add 4. So here's my first term, here's my second term, and then I know what my final term is. It's 120, but do I know what term number it is? No. Well, the problem with using even sigma, the question is, if we had sigma, I could start at 1. Where do I end? Do you see, it's the same issue. I don't know where I'm ending. By the way, we're just going to use these formulas right here. So all of a sudden we wrestle with this and we'll think, well, my gosh, tell you what, for the sake of time, let's just cut to the chase and use this formula from the front and see what we can do. I know that my last term here is 120. I know my first term is 60. I don't know what n is, but I do know that d is going to equal a 4. Now, by the way, this might seem a little bit funny, but you could just subtract 60 immediately. You definitely could do that. Do I need to distribute a 4 here? I could divide by 4. How about that? Look at that. That's clever. 60 divided by 4 is 15. And then guess what n is? Oh, n is 16. This is the 16th term in my pattern. Now, kids will say, why do you need that? Well, in either situation, regardless of what formula I'm going to use, guys, I've got to know what my n is, right? Here I know n is equal to 16. So let's use maybe Baby Gauss's formula here. We'll say it's n over 2 times a sub 1 plus a sub n. They're saying add up your 16 terms here. Here we go, 16 over 2. That's your n. N is 16. What's your first term? Well, we know it was 60. What's your last term? It's 120. And 16 over 2 is 8. 60 plus 120 is 180. And you don't even need a calculator here. We could, work this out. What is that? 1,440, I think? And there you go. That's our lesson for the day.